Today we're going to be talking about one of my favorite projects that we support here at CIQ. We provide training and support for an incredible project called Warewulf. Now, if you were in the know in the HPC environment, you probably have heard of Warewulf, but there's a lot of people who have not. So we have a special guest here today, Mr. Greg Kurtzer. Thank you for being here.
My pleasure. I'm not sure how special I am, but...
Well, I mean, you're special to this topic, today's topic, because you're the one who originally thought of Warewulf and put it out into the world, correct?
I'm the one to blame.
This guy right here, okay? So if there's any issues, go to this guy. So I have several questions about Warewulf and how it came about. First of all, people love to understand where the name Warewulf came from and how you came up with that. So tell that story first.
Oh, that's a great question. Mm-hmm. So the way we do high performance computing is it is a Beowulf architecture. And that we've been doing it this way for ages. And the Beowulf architecture is, it's been very advantageous. Like we've done a huge amount of great science with this architecture. But there was never a kind of standard way or a standard toolkit of building these. There's lots of different ways of building a Beowulf architecture. So when Warewulf came to be, it really kind of pioneered this way of doing stateless systems and at scale in a single system image kind of management style. So it was really a software implementation of the Beowulf. So Warewulf is where it came from, which also is a really interesting side effect, which is the way most people spell werewolf is totally different from how we spell werewolf, because we spell it Warewulf, which is super interesting because now I never ever know how to spell the dog human monster werewolf thing. Like I think it's WEREWOL.
I don't think I know anymore either. Yeah, I think it's an O. I think it's supposed to be an O.
It is forever.
It's going to be a U.
Forever messed me up.
That's awesome. Yeah, I actually heard somebody the other day pronounce it Wolf.
Wow.
Yeah, I'd like to hear more about Warewulf. I thought that was kind of fun. Just wanted to share that with you. Cut that part out.
No snips. We're gonna keep all outtakes
forever. Okay,
y'all see us how we really are.
Oh, that's
totally
amazing.
Not fun.
I love it. So where were you exactly? Like, what was going on in your world when you thought, hey, we need Warewulf? I need Warewulf, so I'm gonna create it.
So this started when I was at Berkeley Lab, and I was hired into Berkeley Lab as a system administrator, and my first kind of group that I was working with in Berkeley Lab was the Earth Sciences division, and started off being system administrator, really kind of focusing on Linux, and I did a few other Unixes and whatnot. And then, but they had a need for high performance computing, and that was one of the reasons they brought me in, is because I have a background in science and already started doing some work in high performance computing. So the first big cluster that they wanted to build was, it was not gigantic, but it was a good sized system. Now, I'm the only system administrator in all of Earth Sciences. So it was, and I was already doing a lot of work. So now all of a sudden, I think I had at the time like 50 or 60 separate servers that I was maintaining and whatnot. And those were mixed, by the way, of Linux and Unix always being kind of a higher effort of maintenance than Linux. But so I had a full load. I was doing a lot already. And then they asked me to go maintain, a significantly sized cluster. I don't remember exactly how many nodes it was, but it was pretty big, and it was using, just to kind of date this a little bit, it was using Miranet for the networking fabric, and it was kind of a big system. And I was looking at it, and I'm like, that's a lot of computers to maintain. I'm already maintaining a lot. Now you want to like triple the amount of work that I'm doing, amount of systems. Like, there's got to be an easier way. And so there were some tools already out there. Three main tools that I thought would be super interesting to kind of look at and evaluate. The first one was a system called ROX. Another one was a system called Oscar. And lastly, there was one called Skilled. And I looked and evaluated these 3 systems. And each one of them kind of had benefits and it was doing cool things. And maybe, a couple cons, at least in my mind, of things that I'd like to do differently or do better. So I basically was looking at these and I said, I think there is a better way of doing this, or a way that I actually prefer. Now, I came from a company called Linux Care. By the way, you didn't say this had to be a short story, so sorry.
No, we're going with that. This is the whole story.
So I came from a company called Linux Care.
Yeah.
And at Linux Care, one of the things that the company was really known for was creating this really cool little CD-ROM image that was called the bootable business card. And on this bootable business card, and it was called the business card, by the way, because it was a single CD-ROM. So if anybody here remembers CD-ROMs, it's kind of old, I guess, at this point. I don't know. I remember 8-tracks. So
right.
Yeah, the gray and the beard.
My first car had an 8-track.
That's awesome. I was going to say, the gray and the beard, I don't dye it to be gray. So it actually is gray. So I'm old. So anyway, the CD-ROMs, most people think of them as like the 5-inch size. Mm-hmm. There was a 3-inch size.
Did it have like a flat side and then 2 round and then flat?
So the CD-ROM singles were the 3-inch. Okay. And if you have any old CD-ROM players, that have the little tray that ejects out and whatnot, and you put your CD in there, you may notice, if you look at the old ones, there's 2 rings. There's the ring for the CD-ROM that most people have, and then there was a smaller ring.
Right.
The smaller ring is for what was called the CD-ROM single. And you're exactly right. The bootable business card took that CD-ROM single and sliced both the edges off of either side.
Yep.
So that little single CD-ROM could actually fit in your wallet. So it was called the business card size. So it was a bootable business card. And on that CD-ROM, we put an ISO image that boot, just like an installer would boot or anything would boot, but it booted a live version of Linux. Now, today, this is nothing fancy. We're going back 25 years ago where this didn't exist. So I promise this actually relates to Warewulf. I'm not just like reminiscing and just having a great old time. So this little bootable business card was super innovative and super interesting. And there's a lot of cool stories I can talk about regarding the bootable business card. That team that did that was fantastic. Like, that was one of the coolest projects that existed in my mind. And it later gave rise to things like Knoppix and the compressed loopback file system, SquashFS, and other types of file systems like that. So going back to the story now, I believed when I first started building these clusters, I'm like, all of the world's problems could be solved.
All of them.
All of them with a bootable CD-ROM business card type node image.
Okay.
The first version of Warewulf that I made, I coded this whole thing up to basically say, okay, in all my computers, I can make not little, but they were full size, but they were bootable CD-ROM images of the node operating system. And the way that it worked is you had this template of your node operating system. And from that template, it would say, you would basically tell it, go burn node 1. And it would actually go and burn it to the CD-ROM. They say, insert disk, insert blank CD-ROM, insert it, and it'll go right to it. And then you take this and you write node 1 on it, go over to your node 1, put it in there, turn it up, put it on, and turn it on, and now you have node 1. And it's running your whole operating system. There's no hard drive or anything necessarily in there, but everything's running off that CD-ROM. And you do that for each one of your nodes, which works great if you have like 10 nodes, 15 nodes. Because every time you update, you have to burn a new CD-ROM image.
Right.
And then you have to burn it for each one of your systems. So it's like, yeah, that's a lot of CD-ROMs to go constantly be burning. Those of you may remember, again, the grays and whatnot, that you used to be able to buy these in 100 disc stacks. Yeah, I bought a lot of those. And so I went to a Linux World to show this off. And Linux World used to be a thing.
We were talking about that today.
Bring Linux World back, right?
You heard it here.
We're going to do it. Let's do it.
Bringing it back.
So anyway, continue back into the story. So I'm thinking this is the coolest thing ever. All the world's problems could be solved with a bootable business card or CD-ROM, and I'm going to show this off. So I show it off, and a bunch of people really liked it. And what they liked about it was what we've done is we've centralized the system administration to a single image. So you have one node, virtual node image, virtual node file system that all of your compute nodes can leverage and can scale from. And so I brought this to a bunch of peers, a bunch of people, and they're looking at this and they're like, we love that part. You nailed this. Like the system administration side of this is so cool. But Greg, seriously, what the heck are you thinking with these CD-ROMs? Like, come on, that is, what a waste of plastic, among other things, like, and a pain in the butt. Like, haven't you heard? There's the ability to net boot, and there's this Etherboot booth just right over there. Etherboot was the predecessor to Pixie, for everybody who's curious about what the heck Etherboot is. So it's predecessor to Pixie. So a couple of people brought me over to the Etherboot booth and introduced me, and they showed me how it works and what it does. And it was so similar in boot process and methodology that it literally took less than a week for me to transform all of Warewulf to use Etherboot. Now, the thing about Etherboot is Etherboot at this time there was no Pixie boot. Like today you have a network card or a network chip, and you could just use Pixie boot and just bring it up on the network. It didn't happen like that with Etherboot. Etherboot had this ability that you can flash the ROM in your NIC, so you can actually like burn it to your physical like device.
Okay.
But the way I always did it is it also came with bootable floppies. Again, kind of dating myself here, but you can actually take the Etherboot image for your NIC and put it onto a floppy, and then put a floppy into your drive, and then that will load an option ROM into the BIOS, which makes that network device bootable. And then it boots, and then it downloads the image, and now all of a sudden we have NetBoot. And then that was the first actual released version of Warewulf 1.0. And what that now gave me, this is like the longest answer to a question that I think I've ever done. But with that said, that's actually saying something, because usually I have a long answer. I think this is the longest. So what this now gave us is this ability to netboot any number of images at massive scale. So it doesn't matter if you have 10 nodes or 15 nodes or 100 nodes or 150 nodes or even 1,000 nodes. We can now boot them all over the network at scale. And if you need to change your image and literally just reboot. And that was what made Warewulf initially so super special. The entire system was stateless. And what this allowed me to do is to maintain a large cluster without having to really scale my time linearly. So let's just say the system was 500 nodes, a lot of systems to maintain. From a software perspective, it's only one. It's only one image. It's all the same.
Right. Yeah. So that was quite a long time ago, right? Was that the early 2000s?
Are you talking about when I started this story?
Yeah, exactly.
Because I think it was about the 2000s when we first started talking.
Wait, are you done yet? Yes. So when was this Linux World conference with the discs and all this stuff? 2001. Okay, so that was quite a long time ago. And then what happened with the project? Like there wasn't GitHub back then, right? Like where did the project go? How did you share it? How? So
there's a couple things that people are going to poke fun at me about.
Oh, okay.
And please go right ahead.
The list is long.
The list is long. Yeah, thank you. I really appreciate that. I love you too.
Okay,
so,
good.
Yes, the list is long, actually. So there's a number of things that 24 years ago, was kind of standard mode of operation. So I hosted a Subversion server, which is the kind of the successor to CVS, but used Subversion, and it was coded in. And now you're gonna really judge me, but it's coded in Perl. And I knew two languages really at the time, which was C and Perl. And I'm like, yeah, doing this in C will literally take me a decade to write. So I'm like, yeah, I'm gonna code this in Perl, much faster. So I coded it in Perl, posted it to Subversion. And the way the project got out there and got well known is there was a website at the time, and again, all of you graybeards out there are going to, or gray, if you don't have beards, gray hairs, whatever, are going to remember that there was some websites out there. There was SourceForge. I didn't use SourceForge for this, but there's another one that was within the same kind of family, which was something called Fresh Meat.
Okay.
And Fresh Meat was an open source site where people can publish projects that they're working on, updates, and
Awesome.
and you have different classifications for these updates and whatnot, so you can kind of subscribe to. I want to know every time there's a release in like HPC, or I want to know be notified every time I can follow the Warewulf project without actually using /dot or anything like that. So I posted a Fresh Meat, and I learned the open source mantra: release fast, release often. The reason why is every single release, Fresh Meat will post it to the top of their list, and then it kind of goes down over time as other projects. So the more often you release, the more often you get kind of top of page, front page headlines at Fresh Meat.
Okay.
And everybody looked at Fresh Meat at the time. So I would release fast and I would release often. And lots of point releases. Probably did about a point release every week and a half to 2 weeks, and getting updates out there. I was part of the Warewulf.org mailing list. I was part of other user groups and whatnot. So talking about this, working with other people. At some point, there was a magazine called Cluster World Magazine, and the very first issue of it, and there wasn't many of those issues, but there was the very first one of it was all about Warewulf.
Do you have this?
No.
Oh.
But I know where to get it.
Oh.
Doug, if you watch this.
Doug.
You know Doug.
Okay. Okay.
Doug.
I want to see this.
I'm going to call you
this.
Doug.
This needs to happen and be somewhere and framed and whatever. Okay.
Oh, and
Carry on with the
Jeff,
story.
Doug and Jeff.
Okay.
They will know if they watch this. Like and subscribe.
Oh man, that was good. I like that. Okay, so now that has happened. And then when did you continue to work on this on a regular basis? This release fast, release often? Like how long were you really involved? Because at some point you kind of stepped away from it. And where's that happening?
So, didn't step away, but what I did was, like many projects that I worked on, it was weekends and evenings. It was not technically sanctioned as part of my day job. There was not it was at Department of Energy. There was not a grant or allocation of money to go and to make Greg's life easier. Like there wasn't. So to make my life easier, I had to do it in the evenings and weekends.
Right.
So I actually did a bunch of open source projects in the evenings and weekends. Excuse me. And Berkeley Lab, UC Berkeley, and Department of Energy were always really so helpful and supportive of that. So I coded this in the weekends and evenings, and over time it just kind of started taking off. It started building up some speed. And at some point, I remember Berkeley Lab was looking at how we're maintaining our systems, and they wanted to do some publicity around how we maintain our systems, because we got really good at this in the HPC group that I was in, and we got really good at this. And my position changed, and I became senior, and then I became lead architect of the HPC group at Berkeley Lab. And so we started kind of doing more of this, and other sites started looking at how we're doing this and whatnot. And so the project kept growing and growing and growing, to the point where another lab, Los Alamos National Laboratory, was building a system called Roadrunner. And Roadrunner is fairly well known because it beat a whole bunch of the records out there. And interestingly, it used the Cell chip, which is the same chip in the first version of the PlayStation, if I remember correctly. If not, I'll comment below and tell me how much I don't know anything. You will anyway. You don't need my permission. I know you will anyway. So you can also tell me I'm right. That would be totally cool. But,
Not as fun though.
Yeah, nobody will do that. So anyway, sorry, I'm interrupting myself and losing track. They make this out of the Cell processor. And the Cell processor at the time was super fast, and it was one of the first kind of real accelerators that people were using outside of a CPU. And but it required all these programmers to go and develop differently for that Cell processor. But it turned out to be, again, one of the fastest systems in the world. And it was the first system, if I remember correctly, to beat the petaflop, or to surpass the petaflop barrier. and which was awesome. And so when they were building this, so IBM was building this, and IBM was planning on using a system called XCAT to build this system. And XCAT is another provisioning and operating system management system, but I believe Los Alamos or IBM, somebody, decided that they wanted the system to run stateless, something that Warewulf is, again, really, really good at. So the XCAT team, or lead specifically, Egan Ford, hi Egan if you're out there, awesome, brilliant engineer and architect. We started working together a little bit to get Warewulf and XCAT to play nicely together. I believe Egan used to call it Werecat, and which is kind of funny. So Werecat really ran Los Alamos, Los Alamos' supercomputer Roadrunner at the time. And not a lot of people know that it was actually running Warewulf underneath. Now later on, XCAT kind of continued development. At the time it wasn't open source. Then it became open source and they implemented their own stateless system within XCAT. So many people who have been running XCAT more recently know it to be its own stateless system, but it didn't start off that way. It started off leveraging Warewulf. So I contributed to Roadrunner in some cool way, kind of.
You did. Okay, so at what point, so you said that you were always kind of involved with the project. There was a point at which the project, because now it's matured in a totally different way. So what role did you play in the rewrite of Warewulf into Go?
Oh, 100% for the rewrite.
Okay.
So you asked about if there was like a hiatus, and I guess actually, I said I didn't step away from the project, but I definitely had other things going on that kind of leveraged a lot of my time. A container system called Singularity is something I wrote as well while I was at Berkeley Lab initially, and then took it out of Berkeley Lab as I became an entrepreneur. Also, Warewulf had some interruptions through the creation of Chaos Linux and even CentOS, because CentOS happened after that. I remember a few people actually in IRC trying to battle to get some of my time to work on the different projects. That was kind of fun. Really great for my ego, by the way. So,
Yes, it is.
So, what was the question? Oh, yeah.
The rewrite.
Yeah.
To Go.
So Warewulf 1. The first version of Warewulf, again, Perl, and it did things in its own way back then. I learned a lot from Warewulf 1. Warewulf 2 was pretty much an entire re-implementation of Warewulf. It did things different, configuration files, syntax was different, everything was different, but it had the same like kind of major premise and how it worked. It's set up, how everything is configured, its ideology, etc. So everything was kind of the same from that perspective, but it was implemented very, very differently. So system administrators and whatnot, it didn't translate. Like where everybody using Warewulf 1, it was a kind of reinstall, reset up for Warewulf 2. Now, Warewulf 2 continued to increase in terms of popularity and got lots of feedback and lots of people who had a lot of opinions about how things should be done. Because the open source community has, we're not shy on opinions. There's a lot of them.
Well said. Very delicate.
So what we did was I asked around and I said various sites and people that I know were either using Warewulf or interested in using Warewulf or interested in the provisioning system. And I asked and I talked to a lot of people. And I said, so if you wanted this provisioning system, if you wanted to use this, like how would you do your provisioning? Like would it be over HTTP? Would it be over a file system like Lustre? Would it be over like all these different sorts of ways? And what do you want your backend data store to look like? What do you want your configuration syntax to look like? And how do you want all this stuff to kind of work and fit together? This might be surprising. Everybody said something different. So at the time...
Not totally surprising. Everyone's a unicorn, right? Every environment. They like to think so.
Yeah. We are all completely unique. Totally unique.
Everyone is completely unique.
We have that totally in common. Anyway. What's this? No, it's you are totally unique, just like everyone else. That's what it is.
I like that.
So, anyway, everyone had their own opinion about how this needs to work, what does it need to look like, etc. So I spent a huge amount of time trying to make everybody happy in Warewulf 3. And I I set it up such that every part of it was modular. And in Perl, it's not the easiest thing to do. So I created all these abstraction interfaces, inheritance designs, and whatnot, so everything can be modular and people can have their own subsystems, their own events, and all these sorts of things. So set it up so everybody can do it differently. How many people do you think actually wrote any external modules or any actual configurations to have it do anything different?
3.
None. 0.
Okay.
Not a single person. But I tell you what it did give us. It did give us a maintenance headache to try to maintain this code base that has so many layers of abstraction and indirection and whatnot, such that we can do anything.
Yeah.
In terms of provisioning. At some point, I actually did use this because I was investigating different ways of doing scalable provisioning. So one was, just standard TFTP, one was HTTP, one was BitTorrent. Actually did use BitTorrent for doing provisioning. Another one was something called XGet, which used the Plan 9 file system implementation to do parallelization of threading. I did multicast. So I tested all these different things. A dolly ring. I tested all these different mechanisms. By the way, the dolly ring was the best, but it required all the nodes to boot in complete parallel and unison, which doesn't happen, as most people know. But that was the fastest, if anyone is ever curious. So, but I tried all these different things. And XGet was the most robust, but it wasn't fully maintained at the time, and it was still kind of an experiment. So anyway, sorry, side tangent. What was the question again?
So the different versions, there was a different focus for each version. So now you're on version 3 where you're trying to please everyone, okay.
And coding.
Yep.
So Warewulf 3 kind of remained for a long time. It had a very, very long life. And open
people are still using it, actually.
Oh,
there's
a lot.
Yeah.
Open
in
HPC.
the Warewulf Slack channel, there is a Warewulf 3
Yep.
subsection, and people are thriving in there. Yeah.
And Open HPC it was actually using it up and even until just recently.
Like last month. This month even, maybe. Yeah.
Actually, no, just to call it supercomputing, I believe they announced that they're now moving to Warewulf 4.
It's been a couple months. Yeah.
Okay. So now.
Okay.
A few years ago, I said, okay, you know what? Let's move on to Warewulf 4. And a couple things kind of became totally obvious and apparent. The first one is that a VNFS, the virtual node file system that we talked about, doesn't have to be managed specifically through Warewulf. It's a container. And as long as you think of it as a container, almost the entire container ecosystem, all of the containers in Docker Hub, everything, can theoretically translate to a Warewulf node image.
Okay.
So I spent some time kind of reintegrating and rethinking about how are we going to pull all of this together, the container ecosystem, Warewulf, booting, all of this stuff. And so that's what we started kind of building and thinking through. And that was kind of the main gist of Warewulf 4.0. Now, the whole container ecosystem, including Singularity, not the first versions of Singularity, first 2 versions of Singularity written in C.
That's
but
right.
The third version, and I wrote the first 2, and then Cedric led the development of version 3, and he translated that to Go. At this time, I did not know Go, and I said, I am too old to learn yet another programming language. So I didn't want to, I'm like, no, I don't want to do it. I'm grumpy. And so, but then came time to move Warewulf to this. And I said, you know what? I'm going to learn Go. And so I sat down and started coding it. I first actually created a little user group around next version of Warewulf. And we had anywhere from 15 to 25 people that would join off and on. And we had weekly meetings and whatnot to kind of identify what are the features that everybody needs and whatnot. And instead of taking the same path as Warewulf 3, where I said I'm going to do everything to make everybody happy, I basically listened to everybody and then I made a bunch of decisions and said, here's how it's going to work. And coded it in Go, as I said, and then released that. I think I wrote, as a matter of fact, I'm 99% certain I wrote almost 100% of the code in Go for the first release of Warewulf 4.0. From there, started getting more people from the community involved. OpenHPC team got involved. SUSE has been involved. SUSE has been a fantastic contributor to Warewulf.
True.
Love the SUSE team. They've been so awesome. And we've been now in typical open source fashion, we've all been coding on this. We've all been contributing to this. And others have now taken on more of a leadership role within the project. So I'm just now just kind of an overseer, and which is a technical term for complainer, just so everybody knows. And I basically just kind of watch and I see how things are going, and I'm there for advice and whatnot. But the team has been doing fantastic in terms of taking it and continuing the development and bringing in new features, new capabilities, and things that I either wanted to do and didn't have the time, or things I didn't even think of that are so much better and bigger than I even considered. So Warewulf has continued to develop, and Warewulf 4 is out there right now. OpenHPC is now standardized on Warewulf 4 as well, and Warewulf's doing fantastic. CIQ is now doing a bunch of additional development around Warewulf, and just a foreshadow. Sorry, words are hard sometimes.
That was fun. Forecatter.
Forecatter.
I feel like that should be a word.
I know. At some point, I actually said docularity, thinking of singularity and Dockers, and I actually did that in a public forum at some point. So anyway, there was I lost my train of thought. I'm doing that a lot. I think I need some coffee.
That's probably accurate, but I need to get to the airport actually. So we're going to finish this little interview.
That
here
is code word for Greg, you talk way too much.
No, this is actually really fun. We're getting to the part that we kind of wanted to get to, but like all of this lead up and understanding the backstory is actually really interesting and really helpful for me. And I think for the community as well. Like sometimes when you know why and where something came from, then it gives it a little bit more context and you go, oh yeah, that is something that I can use in my environment. So where is Warewulf at currently right now?
Oh, and I do remember, by the way, what I was going to say.
Cool.
So the plane can wait.
Okay. I'll tell them.
Just tell them to hold. This way, you'll be right there. CIQ is now putting in some additional features, sort of foreshadow.
There you go.
CIQ is putting in some additional features right now around APIs for Warewulf, so you can actually communicate and do things through Warewulf via an API. And we're putting in a lot of that effort because some of the other things that we're building, like Buzzball and whatnot, is going to leverage the Warewulf API. And we're building a GUI that's going to go on top of Warewulf. And that's something that has been asked for so long.
Yeah.
So we're doing a graphical environment. I've seen pieces of this. This integrates with Copilot, with your existing kind of system configuration, and it just fits right into that. And now you've got a GUI for Warewulf. That will be part, so the API, of course, is completely open source. That's going to go with the project. The GUI is going to be part of CIQ's value add. So if you're interested in a GUI for Warewulf, come give us a call. We're also working on, here's another little bit of foreshadowing, we're also working on, and going to be releasing here very shortly, a turnkey HPC stack that is completely compatible and compliant with OpenHPC and Warewulf v4 with a GUI.
Wow. So when you say turnkey, what exactly does that mean?
Well, imagine if you
download something, boom, your cluster is up and running.
Almost. It is everything you need for an HPC system. It'll include the installers, it'll include the repositories, it'll include the containers, because remember, Warewulf operates on containers now. So it'll have the access to the repositories that have the containers. So you'll be able to import those containers that are pre-made node images, which are fully compatible with the rest of the image. Over time, we're going to have different types of node images. So we can have IO nodes, we can have compute nodes, we can have visualization nodes, all sorts of cool stuff that you can import into Warewulf and then provision out to your system. So lots and lots of cool stuff.
That's really exciting. So what about this debate between the... You okay?
Totally okay. I was trying not to like cough into the mic.
Okay. What about this debate between the stateless and stateful? From what I understand, that once you understand how Warewulf actually works and what you can do, and in your environment, what it is that you want to do in your environment, then people kind of calm down about that a little bit. That's a question I get often.
So, for the last 24 years that Warewulf has been in existence, people have been debating, are you sure, Greg, that stateless is the right way of approaching this? Yes, I'm sure. Now, you may not believe me, I look forward to having that debate with you. Let's talk about it, and you may win. There's lots of cool ways of thinking about provisioning where state actually has some benefit. So we have been thinking about how to do stateful, excuse me. As a matter of fact, there are some ways to do stateful in Warewulf today. So
you can. There's just a little extra manipulation that you got to do, something with an overlay.
Yes.
Yeah.
We can do it.
We can.
But even just because we can doesn't mean we should. And I have a feeling that a lot of the people end up wanting stateful because it feels more comfortable for what they're used to. They're used to managing systems that have hard drives, that have an operating system. You can SSH in, you can manipulate your operating system, and that's a persistent action. So people are comfortable usually with what they know, and completely fine. But I will say that there are a lot of advantages to using stateless. There are some disadvantages as well. I'm deluded in many, many ways, but not everything. So there is some advantages, and there's some pros, and there's some cons. So you have to be able to balance the pros and the cons, and let's figure out what makes the most sense. And if you want stateful, let's figure out how to do stateful using Warewulf or something else. Doesn't matter to us. Like, we're here to help. Sure. So whatever you need, almost.
Can't help you with a haircut.
Maybe we can.
Funny in my mind.
maybe we can.
Okay, maybe. I mean, give me some scissors. I don't know if you'll like it, but I can cut it for you.
I have cut hair before, so
Okay.
just saying, like the Zohan.
Oh, that's amazing. So there's probably a lot more questions that have come up, even though we probably answered a lot. We gave you a lot of history. It was really fun. Thank you so much for coming in and all the good work that you've been doing and being pulled in all a million directions. And I actually didn't know that you were still so involved with Warewulf communities. That actually makes me really happy.
Thank you for coming out here. I mean, I didn't have to fly to here.
Yeah.
You flew here.
I did.
I mean, you didn't fly.
Well,
The
not
plane
with
flew.
my arms. Okay, guys, we're having way too much fun here. So definitely, and I'm out.
All right, we're being cut off. Our directors and producers are now saying it's time to cut it off. We've talked too much. That's on me. Sorry. Rose, as always, thank you.
Yes, pleasure.
Bye. Let's see. Okay, recording. So there's actually a really super interesting story. So at some point, Berkeley Lab was setting up the system for geophysics. And as part of this, they were, this was the first InfiniBand system that Berkeley Lab actually built. And we bought the system from Dell, and Dell had a great partnership with the NCSA. And so the NCSA and Dell said, let us work with you to optimize and build this InfiniBand cluster. And to show you how new this was, OFED wasn't even OFED at the time, and we had to check everything out from a head of CVS. Like, this was like totally not, production release software, not even a little bit. So what we did is we built this up, and the NCSA said, well, we know how to build a system. And I don't remember what system that they just built with this InfiniBand. So they said, like, let's just emulate the whole software build that they did. And so we got the hardware, we rolled the hardware in, and we went through the Dell Merge Center, so everything was already ready to go. It was awesome. Put up all the racks, stitched them all together, built the InfiniBand fabric into a fat tree, big old fat tree, and then started doing the software install. Now, the NCSA they did it pretty quick, and they were happy with it. And for all practical purposes, I think they did fantastic. It took about, if I remember correctly, about 4 days, maybe 5, to get the full software build going and get the software application validated and everything done. So it didn't take a long time, but it took a good amount of time to kind of do it and get everything going. But we built it using the same system image and everything that they did at the NCSA, which was they based it on ROX. And ROX is a great provisioning system, great management system and whatnot. And I feel like it did really good on this, but we don't use ROX at Berkeley Lab. We wanted to use Warewulf. So it took almost the entire time in the afternoon, on Friday, right before everyone was ready to go. Everything was qualified, software application was working, everything was good to go. And everyone's like, yay, it's great. Let's go have dinner and celebrate and whatnot. And I raised my hand. I said, hold on. We said we were going to run this with Warewulf, not rocks. And so everyone's like, you're joking, right? We are not going to reinstall this whole system right now with Warewulf. So, well, I was like, no, I'm actually not joking. Like, we're going to redo this all with Warewulf right now. So in order to just make it so we didn't have a whole bunch of wasted work, just in case Warewulf didn't work, we put a new hard drive into the control node. So we can always go back just in case. Although I knew it wasn't necessary, but I wanted to make everybody there comfortable that all the last few days of work that everybody did isn't completely wasted. So what we did is we put in a new drive, reinstalled the system, installed, I don't remember what version of CentOS it was. It was a long time ago, so it was probably CentOS 3 or 4 or something like that. And rebuilt the system with Warewulf. Now, from start to finish with Warewulf, I think it took 2 hours. And then we were qualifying the jobs, qualifying everything, and everything worked. So we were able to stand up the whole system in a couple hours. It might have even been faster than that. I actually don't remember, but it was within a couple hours for sure. And the NCSA was, the people that were there were so impressed with how fast and how quick and how easy Warewulf was to use that the NCSA actually at that time started evaluating Warewulf for them to use internally as well. And we were able to rebuild that whole system and get everything working super fast. There was also a very interesting slight performance increase with using Warewulf. Now, it should be noted, we didn't rebuild all of the binaries either. So we were even using the same binaries, the same geophysics binaries. We're using the same binaries that ran on rocks before. And I believe, because this was a fairly big system, I believe that the difference is because Warewulf just didn't install a bunch of stuff. Like by default, it was very, very, very minimal node images. So there wasn't any other services running. There wasn't any daemons, system daemons, or processes, or anything else that was running. So it was less operating system noise and whatnot. So I think it just ran super efficiently. Now, I don't know if it would have had that much of a difference, but we definitely saw a little bit of a speed increase. And that speed increase was very welcomed by the geophysics scientists who were there helping to qualify the software. So at the end of the day, everybody was super happy with Warewulf. We were able to do it, still make all of our timelines, and we still all went out to dinner together. So it was a great experience.